What's up, everybody? This is Matt Brown with another IoT hacking video. Today we are discussing a news story that just dropped about a number of online retailers in the United States removing the listings of a number of devices made by Chinese manufacturers, specifically a lot of security camera vendors. And so we read here in this story that the FCC has pushed to crack down on a number of very specific Chinese companies that produce, among other things, surveillance cameras. And so we can see here a number of the companies in the list. We have Huawei, we have Hikvision, whose camera I have right here, and the topic of our video today and the target of our hacking will be Dahua technology company. So I have one of their devices over on the desk, and today we're going to demonstrate not one but two vulnerabilities I discovered in this security camera. So, but why should you trust me? Who's this random guy on the internet? My name is Matt Brown. Like I said, if you're new to this channel, I am an IoT security professional. That means it's my job to find security flaws in devices like this. Well, how good of a job do I do? I have won some bug bounty competitions where I have found vulns in Amazon's devices and a bunch of other Fortune 500s that I can't talk about. So, the other thing that I do is this YouTube channel, and I love to share my knowledge with you about the connected device security world. So with that out of the way, what are we going to demonstrate on our device over here? Well, let's actually go over to my workbench where I have a pretty simple setup today. We're not even going to be doing any hardware hacking where we're going to open this device up. I actually did about 5 live streams hacking on this device, and we did that. We went into this camera, we took the flash chip off of it, desoldered it, and pulled all the firmware from this device. But today, we're simply going to look at data in transit. So here we have an Ethernet connector, and then over here we have this fancy little power over Ethernet injector. If you're not familiar with power over Ethernet, it does what it sounds. It sends power and data over one Ethernet cord, and it's commonly used in commercial security cameras like this one. So we are going to go ahead and just plug that in, and that's all the hardware setup that we're going to have for today. And we are going to start this device up in a second, but in order to capture network traffic, we're going to use our trusty and reliable network capture tool called Wireshark. And so I am going to just restart this live network packet capture that we're doing. And I'm going to boot the device up, and it's going to take a little bit to come online. So I want to talk about what we're going to be looking at today. So data in transit, it's looking at data as it's moving, as opposed to at data at rest, which is sitting on your hard drive. Are files encrypted? Can attackers get at those files on when they're stored? That's what we're talking about today. We're talking about data going over a network. Now that could be data communicating to another device on your local network, or it could be up to some cloud server, and that's actually what we're going to look at first today. So we can see a number of packets rolling by, and we actually do already see data coming from our camera. And so our camera, for reference, if you're following along, if you're like a technical viewer here, the IP address on my local network of this camera is hard-coded to 192.168.1.108. So that IP is our camera, the target of our hacking today. And so instantly, we see a DNS request. The device is using DNS to resolve the host name here of devaccess.easy4ipcloud.com. And so that's interesting. So I'm actually going to, we're going to navigate over here, and we're going to actually right-click on this and say copy value. And I want to investigate this host a little bit more. Where is this camera sending data? This is clearly not a local network system that it's communicating with, but it's communicating to some kind of cloud server. And so I'm going to ping it, but that's honestly just for convenience. In order to get its IP address, I could use other commands to get that. But we're now going to run the whois command to get the registration information for who is responsible for that IP address. And we can see that it is this Alibaba Cloud LLC company. Now, it is hosted inside the United States. A lot of times these cameras are communicating back to China directly, but clearly this is a Chinese-owned company, but they happen to have servers in the United States. And so, yeah, so we can see that this IP address that it's communicating with is like this Alibaba Cloud hosting provider. And so that's always fun to know where our data is going on the internet, right? But what kind of data is it sending, right? So after that DNS request, we see this TCP traffic that is associated with this TLS traffic. So if you're not familiar with TLS, this is the standard and most popular protocol for encrypting data in transit from a client to a server, so that if anyone is sitting in the middle, in between, they can't, in theory, get at the data. They can't see the data inside of that encrypted pipe between client and server. And so here we can actually follow these communications. So I am going to just put in a Wireshark filter called TLS, and then we can filter down to only looking at the TLS traffic that is being used on this device. So here we see, you know, to that same IP address, right, that it did a DNS request for. We see it send a client hello. The server comes back and says, you know, server hello, and then it provides a certificate. So that is all good and awesome. And then there are some other client hellos down here. So there's not just one request out to the cloud. There's a couple different ones. We're going to dig into that in a minute. But I want to discuss one more thing. So I want to look and see if there's any UDP traffic. So obviously, if you have a little bit of a technical background, you will know that, yeah, of course, the DNS requests are going to show up in UDP, because by default DNS uses UDP. But there's actually a bunch of other UDP communications going on here to some cloud servers, and if I have to, I probably have to get it set up properly. So I'm going to generate some more traffic with the client, the desktop client that goes with this device. Now, it's kind of jank. So we're going to try to log in here, and it's probably going to fail. Yeah, it's definitely going to fail. So I have to close out of this. It always makes me do this every time I restart the camera. All right, the application is running now, but it's not. Let's log in. All right, so I'm actually going to pull up two of these views here, the live view and the devices view, and now I'm going to tell it to log into my device, and with any luck, it's going to come online. Awesome. So our device has come online. This is just the company provided software for streaming from a desktop machine to the camera. And so what we want to look at also, so we found those TLS communications. We're going to attack those. That's going to be attack number 1. But I want to get the data ready for attack number 2. So over here in our live view, I'm going to drag my camera over here. And here's my camera live stream here. And you can see that it is actually live. And you will see that it has been defaced by a number of my awesome followers and the people who watch my live stream. If you want to go check that out and see how I kind of invited people to hack my camera live, go check out the live streams that I have. But we're not going to talk about any of these exploits actually in this video. So here though, we can clearly see that this on my Windows machine here. I'm RDP'd into a Windows machine, and it is connected and streaming in the camera. And this is going to generate a whole bunch of data over here, right? And so here, this traffic is between one of my local networks and another local network, but this is the same protocol that works anywhere in the world. So it would also do this kind of video streaming if my Windows laptop was somewhere else in the world, and it would hit a server and it would come back down. But we see a bunch of this UDP traffic, which is really interesting. And again, just some basics in Wireshark. You can always go right-click, follow, and here with UDP traffic, it'll say, oh, we can follow the UDP stream, which is kind of funny. If that's kind of like a deep technical joke, because UDP is not a stream-based protocol, but we're gonna ignore that for now and just kind of roll with it. And we're going to see that we can pretty much instantaneously ascertain that this protocol is not encrypted. And that's because we see a bunch of clear text JSON data about the camera that is being transferred in this protocol. But it's just, information about the camera, which is obviously sensitive. You don't want this in clear text. But is it really that bad? What, like can they actually get the video stream out of here? Well, the answer is yes. Stay tuned to the second exploit in our video, and we are going to extract some corrupted frames, but we're going to prove with a simple proof of concept that we can extract unencrypted video data out of this video stream right here. So what I'm actually going to do is I'm going to take this and we're going to click on this. Oh wait, I forget. Actually, I already have a PCAP of it. We'll do that later. Let's go to exploit number 1. Remember TLS? Well, these are some concepts that I find can be confusing sometimes. How is the encryption in transit being done? So I'm not going to bore you with PowerPoint slides, but I made some diagrams that I hope will help you to understand at the really basic level how trust is being established when we make these encrypted TLS communications, and how mistakes can be made in these systems. So here is the basics of a TLS handshake. If you're a super technical engineer, ignore this because it's not complete, right? I have a ... So this is the don't get mad at me, bro, part of this diagram. But at its core, the client, so in this case, the client is our camera, and right, it's reaching out to a cloud server. So the cloud server is the server in our diagram. And so the client will say hello. It will send a client hello message, and then the server will send back a server hello message. Everyone's being very, polite at the beginning of this handshake. And then the server will send a certificate. And this certificate is the thing that the client must use to verify that the server is the real legitimate server and that the client is not unknowingly talking to the attacker, which we're going to show in our video. So what does the client do with this certificate, right? Well, at its base, that client has already established some kind of a trust relationship with a root certificate authority. And then through some math and crypto magic, right, this root CA has probably verified that it trusts this intermediate CA. You don't need an intermediate, but usually there's an intermediate. And then the intermediate CA says, I trust the server certificate. And then these two things, usually wrapped together, is what is getting sent in this certificate message. So then the client can perform the math to check that the root CA that it inherently trusts the other things all the way up the chain to the server certificate, and the server certificate has the server name embedded into it, right? So that name that we did the DNS lookup for, that is the name that's being checked out in the certificate. But what if there's a bad guy in the middle? That's us. That's what we're going to do in a minute here. We're going to pretend to be the server, and we're going to sit in the middle. And then to the server, we're going to pretend to be the legitimate client, right? And so honestly, all we're going to do is we're going to pass the hellos along. So hello, pass the hello on. You get the hello from the server, you pass it to the client. Then, when the server provides its certificate, we are going to provide the client with our certificate. Now, what the client should do is right here, it should close the connection. It should say, I don't trust that certificate because it's not signed by the root CA that I trust inherently. Well, but if a device is misconfigured, it'll just be like, that looks like a good cert. Let's connect. Let me send a bunch of important data to you. And so that's what this tool, man-in-the-middle proxy, is going to do in our exploit that we're going to do right after this. It is going to forge a bunch of certificates. So it has a CA that it has just made up on its own that is just a self-signed certificate that just says man-in-the-middle proxy. There's no reason why any client, any TLS client, should ever trust this man-in-the-middle proxy certificate. And then every time a connection comes in to our little imposter server, our man-in-the-middle proxy tool, it's going to on the fly generate all these server certificates that are signed by its root CA. And then we're going to see whether or not the client continues establishing that connection and sending us data. So to do that, we are going to set a couple of IP tables rules over here. And where are they? Here we go. So I have tracked down in the PCAP all of these ports because usually 443 is the port that's being used. Actually, let's go look at this in Wireshark because this is kind of insane. And we're going to just look at client hellos just to, all right, so we're just going to look at all the client hellos. We're going to say apply as filter selected. And here are all of these connections. And you can see that the destination port here, 15301, that is not a standard server port for TLS, right? And then we see another one, 8683. Another non-standard port, 12337, not standard, another 8683. None of these are standard, right? I think some of the traffic under certain circumstances actually uses 443, but we'll get to that in a minute. Oh, actually, I do know how to generate that traffic. We're going to get to that in our demo. So what I'm going to do is I'm going to write a bunch of these IP tables rules, and at a really high level, all these do is it redirects ports, traffic that is destined for all these TCP ports to me and my attacker tool. And that attacker tool is going to pretend to be every TLS server that it can. And so if you want a deeper dive into this tool, the script that I have here, it's called man-in-the-middle router. I will put a link to it in the description of this video, and you might get some value out of it. So I'm going to run this command, and it's going to restart. But I'm going to need to run man-in-the-middle proxy. If you are curious why I had to add this little flag, if you're used to the man-in-the-middle proxy tool and you're like, why do you have to set this weird, TLS version min to TLS 1.1? That is because the server that we are connecting to is so ancient that it only supports TLS version 1.0 and 1.1, not even 1.2, let alone 1.3, right? So it's really old and insecure if you're new to this stuff. That's the long and short of it. Okay, so we are ready to start intercepting traffic. So let's generate some traffic. So the connection is over time. All right, so right here, I'm going to log into the web interface, actually, of my camera, just because I know there's one thing I can do in the web interface that will initiate a outbound connection. Otherwise, I have to wait a while for it to make a new connection out that I can intercept. So the way that we're going to do that is we're going to go here, and we're going to go to upgrade, and we're going to say manual check. And this manual check. Aha! So we have successfully intercepted the request for a firmware update. So that's like great, right? That's probably a security critical operation here. And so you can see This one is actually to port 443 because we don't have like a colon and a port number here. But we can see this is update v2.easy4ipcloud.com. Let's look at what kind of information is being sent in there. So there's some quasi-digest authentication. If you don't know what that is, don't worry. But here we are sending some critical information. By the way, we're sending our serial number, which if your camera has the peer-to-peer connection enabled on our Dahua camera, the cloud connectivity, and it has a really weak password, that's all that an attacker needs is, in addition to those things being true, they need the serial number to be able to log into your camera anywhere from the world. So that's pretty cool. What does the response say? Well, in the response, it gives us a link to the firmware file. I don't know why that happened. Okay, so it gives us this link. See that? Upgrade and some big zip file with firmware in it, right? So, so when we can use that to actually download the firmware, I have done that. So, but here we can see that we are able to successfully intercept this traffic, which is not great. And there's lots of other requests that can be made. Most of them happen when the device boots up, so I'd have to like go reboot the device in order to get that to fire off. But there you go. We have intercepted traffic. We have pretended to be that Alibaba server, and this camera will happily connect to attackers' TLS server, just like this. But that was one vuln. Let's do a second one. So let's go, and now what we're going to do, we're gonna quit out of that, and I'm going to come back here, and we're gonna stop this like intercepting of traffic thing. There we go. And I'm going to come over here, and we're going to go back and look at that UDP traffic. And I'm going to start this over again. Oh, it's still live streaming. That's great. Okay, but I actually want it to stop, and then I want to start it again. Okay, and there's a reason behind this. I want to get a fresh capture from start to end of that video stream. So what are we gonna do? Okay, this is so sketch. All right, so let's actually just close out of this completely again, and then we're gonna go over here and we're going to restart our capture, and then we're gonna go back here. We're gonna open this up. Gonna re-log into the camera. Go to our live view. I think I have to go in here and tell it to like manually log in. All right, online, and we drag this, and we're streaming. Okay, cool. So we're just getting a fresh capture of all of this UDP traffic, which is awesome. So now what I'm going to do is we're going to just let this roll for a little bit. You know, throw some data in the video stream, and we'll stop. So that's enough packets. Like we said last time, we can go follow UDP stream, and we can see there's a bunch of clear text like strings in here, but we want to know like, is there video data inside of this stuff? And obviously this is like a custom protocol. This is why this is difficult sometimes to determine what data is actually in here, because this does not follow any standard. There's kind of a standard, and then they kind of extend it, and so we'll get into that just a little bit here. But first, what I want to do is I want to go. I'll save as and research Dahua, and let's just go and make a PCAP file. And I've already taken one of these, so as a backup, but we will call this live. We're doing it live. All right. So there we go. Now over here I have this PCAP file. So now I have next to it this Python script, which I totally wrote 100% myself. Just kidding. This was vibe coded. Okay, so they're based on, no, I seriously like fed the LLM like information about like some people's research and GitHub repositories about parsing the Dahua P2P protocol, and it kind of came up with this thing. So what it is going to do is we will notice it's going to look for this magic set of bytes, this PTCP, right? And if we go and look at some of this data, we can see that over here, right? We can see how the payload, the UDP payload, a bunch of these packets is starting with these 4 characters PTCP. So this traffic is UDP, right? And UDP is an unreliable protocol, right? It's meant to be lightweight and fast, and the trade-off is that you don't get reliability checks. There's nothing about the protocol that guarantees that, like, if a packet gets dropped by a router, that it's going to get resent and it's going to get fixed up eventually in the protocol. TCP, on the other hand, does give us those guarantees. And what this PTCP protocol is some weird, terrible creation, Frankenstein monster, where they tried to cram some of the TCP concepts into UDP. And so a number of these first bytes in here, so obviously like these ones right here, are PTCP, and then we have these other bytes here, which are it's a header in this P2P packet where it is trying to provide some reliability checks. So again, just enough mumbo jumbo. We just gave the LLM all that information and came out with this. Now in here it is hard coded to look for these 2 IP addresses, but obviously the script could be like fixed to not look for that. But this is my Windows VM, right? And this is the IP of my camera, so we're good. And then we have this function that's going to like go into the UDP traffic, and it's going to find those PTCP packets. And so it's going to do that. We also have a function for extracting H.264 video packets, video data, right? Now I just said this is like a non-standard protocol. Well, it is and it isn't, right? Because it is actually using H.264, but it adds some extra extensions, and they just like don't follow the standard exactly. So you can't actually like automatically recover the video. There's a bunch of reverse engineering we would have to do. But at the end of the day, yeah, it's going to create a H.264 file. It's not really that, right? But what this tool does, yeah, analyze video data. Let's just go down to the part we care about, right? Basically, it's going to take it. We're going to use this tool just like this. We're going to call the tool. We're going to send it a PCAP file and where we want it to output the captured data, right? And so to do that, we're going to go like this. So we're going to run our extractor tool. We're going to send it our PCAP, and let's send it the new one, just to prove that I'm not rigging this. There's a little bit of risk in here. I hope this works. I know there's video data in the other one. So let's run this. Yay! It extracted something. So it put this file. Data.bin has 6.4 meg. All right, we got some stuff in there. Let's just look at that in like a hex editor. Okay, there's definitely something in there. Now there's also all this junk. Like, I don't know. We'll see if this works, guys. So what we're gonna do now is, obviously there's some non-standard H.264 data in here, but what we want to do is we want to extract out some frames, and there's this cool thing we can do in FFmpeg where we can actually try to extract some frames out of here. So let me make sure I delete everything out that was in there. Oh good, it's empty. So what we're going to do here is we're going to try to extract out the first 10 frames that the actual video data frames that it sees inside of this binary. And invalid, of course. Ha ha ha. That's funny. Okay. All right. Did I delete the wrong script? That's so funny. All right, let's try this one. Okay. Now we're going to try our little command here. Hey, that one worked. I don't know why the data was different. All right, we must not have gotten good capture, but obviously we've got a PCAP here, and then it generated the first 10 frames that it could find in that binary file, right? And so, you know, the moment of truth, let's look at them. Uh-oh, this doesn't look like it's accurate. Wait a minute, there's, like, I can kind of see it there. And if we compare it to our actual video stream here, you can see that that is actually, like, this upper corner here is correct. And then whatever parsing, like, there's obviously some parsing that one of the tools that I'm using in this chain is not doing correctly, most likely because there's some very non-standard thing that Dahua is doing. And so we're obviously able to get some of the frames. Oh, here we can like cycle through them. So there's one, here's another video frame, here's another video frame. Like, it can obviously do that first part correctly, and then it all starts to get screwed up after that. So, but we can see up there that we actually have a bit of unencrypted data, which is enough to prove, right? What we can intuitively assume, that all of this protocol is not encrypted, right? And it's because we see all that JSON data, right? Like, we see all of this, like, text JSON data sitting in here, obviously not encrypted. So those are the two vulnerabilities that we found in our banned Chinese device. So the question is now, do you think that this is a wise move by the US government, right? If you watched to this point, thank you for watching, by the way. Most people don't watch all the way. So these devices, right? Like, do we think that security vulnerabilities alone should be grounds from you know, banning a device from the US market? Should United States companies have to play by those same rules? Let me know what you think down in the comments. And as always, thank you for watching. Have a good day.